Hello, I am Kyatric and today I'm making this video for the Construct 2 Academy. The game we will be making is a Simon Says game. A random sequence is being generated, is being played. The game expects the player to reproduce the sequence by clicking the colored buttons. If the sequence is reproduced in a wrong fashion, the game will play the sequence again and when the sequence is correctly inputted, a new sequence is generated with one more step to it. Clicking the play button allows at any moment for the sequence to be played again. The idea in this game is to set a random sequence to remind and memorize a sequence that is inputted by the player and compare both sequences. We will be doing so by using different plugins from Construct 2 and some of the tools like the loops, the arrays, and the functions. Let's see how to set up our project in a first time. Open up Construct, click New Project, make a new empty project. When you hold down the Control key and use your mouse wheel, you can zoom in and zoom out. This is our layout, the visual editor part of Construct. Our project by default has a size of 854 pixels of width and 480 pixels of height. We will set our layout to the same values. So now we have a defined layout which fits perfectly the size of our project. Let's rename right away. Simon Says. You can put your other informations in. We will click the View ribbon tab and check Snap to Grid as well as Show Grid. It will help us align our various elements to keep them in good position. We double click the layout. This allows us to insert a new object, and the first object we are going to insert, the first object type, is going to be sprite. We will mainly have sprite objects. Click in the middle. We will start by adding our Simon 1 base. We can set to bounding box the collision polygon. This object won't really have an interaction, it's mostly a visual element. We'll rename it base just to remember what it's supposed to be. Place it about in the middle and on top. Then we will add the buttons, the color buttons to it. Insert another sprite object, and this time we are going to import frames by right-clicking in the animation frames dialog. Import frames from files. It allows us to select several files and have them directly imported into the sprites. We need to modify a few things. First, the animation speed will be set to 0. We don't want this to be an animation where each frame is swapped for another. We actually want to use that sprite as an image bank of sorts. So each instance is going to display one animation frame and one animation frame only. Another modification we want to do right now is to modify the collision polygon. Right now, by default, it's set to bounding box, and due to the size of the object, you can see it's the big square. It would mean that even if I'm clicking in an empty area of that object, it would consider that this object has been clicked. It's going to be an issue because I'm going to have all the frames according to the same origin point for the alignment. That's why we snapped to grid earlier. But we want that the visual only of the texture as an interaction. So we modify our collision polygon. We simply drag drop the various nodes, and by double clicking a node we add one more. Which allows us to keep very precisely to the borders of our visual objects. And we will do the same for all the animation frames. Another thing I will want to do is actually move my blue frame actually as the last. I would want to start in the top left, then top right. I will go clockwise, but starting with the green frame. And that's it. Construct 2 accepts up to 9 nodes for the collision polygon and strongly recommend to use that limited number, not more, otherwise you are going to possibly encounter performance issues as well as collision issues. Our buttons are set. Name it button and place it. Then I'm holding down the control key and drag dropping the object. It creates an instance of it. I will now modify the initial frame so that it's 1. Now I have my red button, placing it, creating a new instance, changing the initial frame, the yellow button, and a last time for the blue one. And all of them are aligned with the center and the overall base. I'm still adding yet another sprite. Insert. And this time it's going to be my button play frame 0. Add another frame right here. It's another solution to add texture to your sprite object, and select the button play frame 1. By default, you see that the shape of the texture has been used for the collision polygon, but it's adding a bit more nodes than necessary. So I'm just selecting the few nodes I don't really want to keep in check. And again, I don't want an ongoing animation, so I'm modifying the speed of the animation to 0. I'm placing the object, but it's going to be hard with the current grade. Anyway, I'm selecting the instance and using the arrow keys on my keyboard to position the object to my liking. Pretty much designed it so that it's about this position on the base. Rename the object to button play. Add a new type of object. This time we are going to use the sprite font, which we'll use as feedback for our player. just positioning it about here and resizing it, and add a behavior to it. And the behavior is going to be a timer. And this will help us to control the displaying and the switching on and off of the various light buttons. Adding yet another sprite, again from the animation frames, from the files, we are going to take those 4 buttons colors, and we will modify again the blue one to be the last, so that the colors on that object are the same as in our Simon Says objects. It is critical for our logic, we will see it a bit later, since we are going to rely on the animation frames number and order. Again, the animation speed to 0, this is pretty much an image bank, and rename it to sequence inputs. Those are the buttons that are going to be displayed at the very bottom when our user is clicking on a specific button to remind him of what is already inputted. We need a few more objects for our project which are not necessarily visual objects. We will need a way to handle the user's input, so we're adding the mouse plugin to our project. It is in the object type, but you can see that there is no visual part for it in our layout. We also need to add the function object that we will use in our event sheet, same as the mouse plugin. There is no representation of the function in our layout. And finally, we will be adding 2 arrays. The first one that we will rename A sequence. A personal preference of mine is to keep an A on as a prefix to arrays, to remember always that it is an array, and then the name itself of the array. And adding yet another array, and this time renaming it A reproduce. That's all the objects we are going to need. The rest is actually done into the event sheet. Here is an example of an array as it is in memory. We do have our x coordinate 0, 1, 2, 3, 4, 5, 6, 7. So in our case, this is an array of width 8, since we start at 0, our maximum index is 7, makes 8 different cells that can be accessed through each of their coordinates, and each cell contains a different value that we can set, that can be the same in between different cells that we can also get. Arrays can have more dimensions than only one, but for our current example, we are only using arrays of one dimension. You have different cells, each cell has a different value, and when you are using the at expression in construct with an x coordinate, so for example 2, you are getting the value from the array at the cell of index 2. In this example, it's Kyatric. Another example is if we set in the array at the position x number 6, Linkman. That's the name we set, so the value we set. Values can either be strings, so names as you see there, or numbers, and that's what we are going to use mostly in our example. We will be using 2 different arrays, and we'll be comparing the values of each one. one of the arrays is there to contain the randomly set sequence that was played in our example, and the other array is going to be used to remember the inputs of the player. And when we are comparing if the inputs are the same as the original sequence, we can know if the sequence has been reproduced or not, and if the player has won or not. As always with Construct 2, you can go to the manual and check in the plugin reference, for example, for more information on every plugins or behavior we are using and that are available in Construct. The array manual article has some information further on the usage of the arrays. The event sheet in Construct is read top to bottom, and each time an event is encountered, its conditions are read, and if the conditions are true, its actions and sub-events are executed. For example, if you remember our game, the buttons were not so shiny by default. That is done by adding an event of type system on start of layout, add an action, button, and we set the opacity to 45. If I now execute, preview my program, the buttons indeed are less opaque, and you can see through and seems less shiny. The condition on start of layout has a little green arrow, which means it is a trigger. It will be read from top to bottom, but not necessarily be executed at the very moment it's being read. It's going to be executed at the moment where the layout is starting, and it will execute only at that moment. So another action we will want to do at that very moment is actually to call a function that we are yet to write, and that we will name setSequence. So on start of my layout, when it's loading, I'm modifying the opacity of the buttons, and I'm calling a function. A function is the plugin we've added, and add an event, function, on function, and we set the same name, setSequence. So we are calling this function in this event, but the function itself, as you can see, is a trigger as well, and can be placed about anywhere in the event sheet. A function is a bit of code that will be called from an action. Its actions and sub-events will only be executed from the moment it has been called. So on start of layout, we want to set a sequence. And set our sequence is actually to set a random sequence of buttons to colorize and display to our player later. For now, we just want to know what button we are going to be displaying in what order. To do so, we need to add a couple of global variables. The first one is going to be named sequence NB, and we'll have a default value of 2. This will be our number of steps in our sequence. What we will want to do at the very beginning of our function setSequence is to set the value sequence NB to a new number. We actually want to add 1 to it. So that's a way of doing it. I could have done it by using the add to action, but actually I want to also add another expression that is named clamp, and that is going to set some boundaries to my value. So whenever I'm adding 1 to sequence NB, the minimum value possible is going to be 0, although we start with a default value of 2, and the maximum is going to be 12. That's a value I've decided on. You can decide to limit up to 7 if you want. It means that the maximum number of steps that our sequence is going to have is going to be 12. And each time we will call the function setSequence, we will add 1 to the number of steps until we reach the limit 12. It won't go further than 12. And now we start to use our array. First thing I will want to do is to clear the array. In a normal game, it's not very useful because by default an array is containing only zeros. All the values of all the cells of the array when you create it is at 0, and that's what clear does. It changes all the values of the array to 0. But our game is going to be looping. That means that we will be setting the sequence, we will be playing the sequence, we'll wait for our user, our player, to input a sequence, compare that the sequence the player has inputted is the same or different than the seconds we have set, and if it's different, then we play again the sequence and expect again our player to input the sequence to compare it, and if it is the same, we then loop back to this very function setSequence, where we add one more step and make a new sequence. So this is kind of an initiation of the array at that moment. And another thing we need to do is to set the size to sequence NB. So the width, the actual number of cells we are going to have on our one dimension X, is going to be equal to sequence NB, the value we have modified right here. After that, we are going to press the S key or right click and add a sub-event. System, and going for a loop, a for loop. A loop is a bit of code that is going to be repeated during one tick of execution, as long as the loop is valid and going on. For now, name it sec. We start at 0. This is going to be the various indexes of our array, and we go up to sequence NB. And what we do is to set at X. So we set the value of the cell of coordinate X, where X is actually loop index sec, which means that it's going to be the value there that is going to be repeating, and that is going to go from 0 to sequence NB. So 0, 1, 2, etc. up until we reach sequence NB. And the value there is going to be the animation frame we want to display. And so we have animation frame 0, which is green, 1, 2, 3, which is our blue button. We go from 0 to 3, but we are going to use the int expression that is going to return an integer number, a complete number, the random expression that is going to pick a random number in between 0 and 4. If you count 0 to 4, it means 5 values, but the random expression never reaches the right boundary. At best, it will return a 3. A 3 because we want the value to be an integer. So this bit of command there returns either 0, 1, 2, or 3. And we store it in our array, and it's going to be our sequence. So once it is done, we right-click, add a blank sub-event, or can use the B keyboard key, and we'll call a new function that we'll still have to write, named play sequence. So on start of layout, we set our sequence. That means that we call the event number 2. That will initiate a bit of values, run a loop for the length of the A sequence array, fill it with numbers, and then play the sequence according to the values there. We can collapse this event. We won't need to get back to it. We add an event, a function, on function, play sequence. We start by adding a blank sub-event. This is not really useful, but it's just that then you can collapse it and have it nicely sitting. We will want to start up by setting the opacity of our buttons to 45. Keep in mind that we are looping in between our functions. This is something that is going to make sense a bit more later. We modify the text value from our sprite font object to playing the sequence, and we add the expression new line that will jump a line in our object, and the Greek end allows to add the string, which is between quotes, and expressions that can also be variables, etc. Be sure to memorize it. Closing the quotes. We will need to add one more global variable right now, and we are going to name it current sequence step. And by default, the value is at 0. We can leave it at that, and actually at this very moment we are going to modify it and set it to -1. Then we will be starting the timer at a value of 0.1 second, so that's almost immediately going to happen. Play sequence timer. This actually starts a timer for 0.1 second that is going to have the tag or the name play sequence timer. That allows us to add a new event in going into sprite font, timer on timer. It is a bit like our functions, except that it's going to rely on time instead of being called from our code. And we do our play sequence timer, in which we will start by adding 1 to our current sequence step. So from now on, since we have set it to -1, we start the timer. Almost as soon as we did, it happens. We now have a current sequence step value of 0. We go into an event. We will compare the size, the X size, and make sure that it is greater or equal than current sequence step. So this event there is going to happen only and as long as our array size, the width, the X size, is greater than the value of the variable current sequence step. It will make sense a bit later. Again, bear with me, we will get back to it. Just know that we are looping. We will be looping in between this timer and another one to be displaying various buttons light. If you remember our example, you can notice that when it's playing, there is an alternating between the object is colored and the object is not colored, and displaying then the next object. We also need to add another condition to this event, so we press the C key or right click, add another condition, go into the button, we compare frame, and we want it to be equal to a sequence dot at, and this expressions allows us to get a value that is stored in our array, and the value that is being stored, we want the value that is being stored in the cell that has the x coordinate current sequence step. Remember, currently 0, so we want to pick the button that has the animation frame that is in the very first cell of our sequence, and which is the value that we have randomly set a bit earlier in our set sequence right there. So it's a value from 0 to 4. Those are the animation frames, and current sequence step allows us to know at what point we are in our array. We set the opacity of our button to 100, that will light it up, and we start another timer, this time of duration 2 seconds, still happens only once, and we call it next sequence timer. For now we stay at there, make a new sprite font, event on timer, next sequence timer. There we will make back all our buttons opacity to 45. So I'm holding down the control key, drag dropping an action, and it will clone it. Let me get back to this event. Right there, this condition allows us to pick only a single button instance, not all 4, just one, and the one that is going to have the same animation frame as the value in the array. So remember, our buttons are either initial frame 3, so that's our blue button there, 2, 1, 0, etc. So, getting back to next sequence timer, this action there has no specific instance picked, so all the button instances are going to be selected, and the action is going to be applied to all of them. So all the button instances will have their opacity back to 45. And we start again a play sequence timer, but this time we'll modify the duration for half a second. And so remember, we start playing our sequence. We modify the opacity, we modify what is being displayed in the sprite font, we initiate the value of our current sequence step value, and we start a timer. The timer is being executed. It adds 1 to the current sequence step value. It picks the appropriate button instance according to the A sequence array value. It lights up this button by setting its opacity to full, and for 2 seconds we stay in this state. Then, after 2 seconds, we put all the buttons opacity back to 45, and we start again a timer for half a second where all the buttons are going to be switched off. Then it will execute again this very event. Add one more to the current sequence step, so we are moving further in our sequence. So now the value is 1, and we are going to pick the button that has the same animation frame as the value in the A sequence cell of index 1 up until we have reached the size, the total number of cells that are in our array. Here we need to add another event in our timer. So I will press the S key. It's a system special conditions else. This condition only executes if the previous condition, this one, has not executed. So as long as the value of current sequence step is less or equal than the width, the X size of our array, that is to say that we have cells in our array that we can pick a value from, we display it in a button, then switch it off and get back to it. But from the moment that we reach the limit of the array, that we are finished pretty much, this event is going to kick in and will allow us to exit that loop, that timer loop, and give back the hand to our player. So add an action, sprite font, set the text, sequence as ended. Add 2 new line and another quote, please click the buttons to reproduce the sequence. That is feedback to our player. From this moment, as I said, I want to give back the hand to my player. We will add a global variable that we are going to name player input, and by default is at 0. At this very moment there in our code, we want to set the value player input to 1. It's a bit strange again, since we haven't used it so far. Again, bear with me. And a bit like we did in our set sequence, we'll want now to work with the A reproduce array. And we are going to clear it, and A reproduce, set its size, but this time we want the width to be 0. So it means that currently this array does not even have one cell available. We had an event where we check if the player input is equal to 1, which happens only once the sequence has stopped playing, and which means also that all the sub-events that we are going to create will only happen when this value is set to 1. We press the S key, and we will now go and have our first input with the mouse plugin. Cursor is over object button. And when the cursor is over a button, we want that button opacity to be 100. For that to work also, we need the button, the general button opacity set to 45. And this will work because only one instance is being picked. It is the one instance that has the mouse cursor over it. S button, go again to create a mouse event, and this time it's going to be on object clicked, left clicked, we are okay with it, a button. We will have some code that will happen when we click on a single button, and remember we've set our collision polygons so that only this area is going to react to the fact that we have our mouse cursor over it or that we are clicking it. That's why we needed to modify the collision polygon there, to make sure that it was only this visual area that was going to interact with this event and not the whole area. Otherwise we would have had all 4 instances interacting each time we were over the object and clicking the object. And so when we click a button, we will change the size of the array reproduce and set the size, the width, to self, which is a keyword that refers to the instance of the object type we are currently setting the action for. So the a reproduce array, self.width. So we want to take the current size and add 1 to it. So remember, by default we set it so that there is no cell at all, and when we click a button we add a cell to our array. So now there is 1 cell in our array the first time we click. And we also want to set the value at x. So this time it's again self.width, but -1. It is the index, and the index starts at 0 for arrays. The first cell, its index is 0. So as our width currently is 1, we remove 1 from it to have the correct x coordinate. And the value is actually the button animation frame. So 0 to 4 according to the button we are clicking. And it will stay in our array. We add one more feedback to our user. Steps. We make a space right there because otherwise the line wouldn't have any spaces. We add this time the a reproduce dot width value, and we add another quote, this time no spaces, and sequence nb +1. Remember, sequence nb is the number of steps we have in our sequence, the original sequence. We add a +1 there because, again, indexes are 0 based. And to add more feedback for our user, we add an action system create object, and we will be creating a sequence input. It's going to be on the layer 0 because we only have one layer in this project. We'll want the x to be a reproduce dot width -1. So again, the current maximum index for our array a reproduce at that time. We multiply it by 64 because the objects are 64 pixels, and add 32, which is half of the width of our object, and that will allow us to align them as intended. And the y there is 448. This is a value that I've got earlier by simply moving my object in place and noting there that the y position is 448. And last thing, sequence input, set frame to button dot animation frame. We want the sequence input animation frame to be the same as the button we are clicking on, and that's why earlier I wanted and I stressed out that we wanted to have the same order of colors. We were starting with the green, then the red, then the yellow, then the blue, and add the green, the red, the yellow, and the blue. So we are using all the time the same number, and it's coherent. So with this event we are changing the size of our array and storing values within it in a new array, the A reproduce array. And we are making some feedback for our user. But at some point we will want, when actually the same number of inputs, of expected inputs as the original sequence, the same number of steps has been reached, to start and compare both sequences to see if they are the same, if the player managed into reproducing the sequence as intended. So we make a sub-event, S key, of the mouse left button clicked, and we go and check that A reproduce, we will compare the X size, is equal to sequence NB plus 1. Again, like we've had there, our maximum number of steps, sequence NB plus 1, we're making sure that the A reproduce width is going to be the expected number. And from there, we will execute a function, a new function, named compare sequences, and we will set back the player input to 0. We don't want the user anymore to click on buttons while we are comparing the sequences. And so now we add a new event on function, the function compare sequences, where we are going to be comparing both arrays. We start with a blank sub-event with B, right click, add local variable. The local variable name is going to be comparison, and we are going to use this to compare and to know if the sequences are the same or not. Click back our blank sub-event, add the C, press the C key on your keyboard, A sequence, and this time we take the condition for each element, we select only X. So this is again a loop. You can notice the little green round cycled icon, which means that automatically for the length, the width of the A sequence array, we'll be looping through each coordinate, each cell on the X dimension. And we add another sub-event where we compare at X, and the X is currently the A sequence.cur X value, which is, like we used previously, loop index. This is specific to the array. When you are looping with this condition, you can use cur X to have the specific looping value. So now we are going to check that the value at A sequence cur X in our A sequence array is going to be the same as the A reproduce array, the value in the A reproduce array that is in the cell of coordinate A sequence dot cur X. So the very same X coordinate, we are checking that both values are the same. And if both values are the same, we then add 1 to our comparison local variable. Which means that once we are done looping through the array, we know that the arrays have both the same width, the same size, and we check for each values at the same coordinate. Once this is done, we get back to our top event and add a sub-event, press S. We want to compare the variable sequence NB and make sure that it's equal to comparison. So which means that each time that we have the same, for each step, if you will, of the sequence, you have the same value, we add 1 to comparison. And when comparison is the same value as the number of steps of our sequence, we can conclude that the sequence and the reproduced sequences are the same. The player inputted the sequence as expected. So we will add some feedback. Set text. Great job reproducing the sequence perfectly. We skip 2 lines and please click to set a new longer sequence. On the opposite, we hold down the control key, take the sub-event number 18, drag drop it, it clones it like we did for the actions. When the sequence NB is not equal to comparison, it means that not all the values are the same in both arrays. And so the feedback is different. Sorry, your sequence did not match. Please click to play again the sequence. At that point, we're missing something. Add a global variable and name it reproduction success. And set it so that by default its value is -1. Then, in our event where we are successful, we set the value of reproduction success to 1, clone it, and in the failure, if you will, we set it to 0. And so, add a new event. This is a new interaction from our user that we are expecting. That is simply a click, a left click. But, if you remember, player input, at that moment, player input is set to 0. It's a way for us to know that we are not in the same step of our program, if you will. We are not expecting the user to reproduce the sequence on the buttons, but we are expecting the user to simply click. So add a condition and check that player input is actually equal to 0. Also, as a sub-event, S key, compare variable reproduction success. So 0, which is a failure first. What we want to do is to modify the value of reproduction success, get it to its default value back, and actually play the sequence again. So simply function, call function, play sequence. And the way we have designed and made our code so far will simply loop again. We are still with the same sequence, with the same original sequence. We will be playing the sequence again, which now is going to set the opacity back to 45 and loop a bit between the timer, etc. And then give back the end to our user so he can input back by clicking on the buttons. And that's everything we have done so far allows us to game loop, if you will. On the other end, when reproduction success is equal to 1, but we want also to make sure that we haven't executed that event, so we add the condition else. Instead of playing the sequence, we actually set a new sequence. And so we loop again, but we loop back from up there, where we add a new step to our full sequence and make a new sequence from scratch. By the way, right there, we will need to add now set value player input to 0, and we will need to add as well set value reproduction success -1. I haven't added it earlier since it was late in the process, but it makes sense since we are looping to initiate those values right there according to our code. So if we test it, it would work as intended. We're previewing. It's playing a sequence. Expecting us to reproduce the sequence. And when we have reproduced the sequence, we click and it makes a new sequence. Something we forgot right there, you can see, is to destroy those objects. This is something we'll get back to. And when we are wrong in our sequence, here it is. So as I was saying, we forgot, for clarity's sake, to destroy the instances of the sequence input object, and those are actually happening when we play the sequence, because play sequence is a function we get back to on several occasions. It happens when we have finished setting a new sequence, when we have inputted a wrong sequence, or when we will also want our user, our player, to click on the button play. That's a last event to add. That's on left on object click on the button play. We want the button play frame to be 1. We want the player input to be set to 0, because it's going to be playing. We don't want our user to be inputting something. We'll use the wait action, system action, which will actually wait for 0.45 seconds, it's a value I've decided on, before changing back the frame of the button play object to 0. This is how we can give the impression that we are clicking on the button and that some animation is playing, and that we are calling the play sequence function again. Now, if we preview that, our sequence is playing. Let's say I'm starting wrong, I know. Oh, it's not the good one, I think. Let me play back. And the sequence, so we have destroyed the objects right there, the instances, and it's playing our sequence as expected. And we did a great job reproducing the sequence. And here is a new sequence. So that is how you make a Simon Says game in Construct 2 with the usage of functions that are placed and used in such a way that the logic of your game is looping. We have divided our logic into certain steps. First, set a sequence. We have a way to play this sequence, and playing it is independent from anything else and leads us to give back the end on our user when we are expecting some inputs from her. And once all the inputs have been done, we then compare the sequence, which allows us to branch out whether we are successful or not. And according to success or no success, on a new interaction from our player, we are either getting back to a point of our logic, playing the current sequence, or the player has reproduced the sequence, so we go and set a new sequence. As always with Construct 2, you can go to the manual and check in the plugin reference, for example, for more information on every plugins or behavior we are using and that are available in Construct. The array manual article has some information further on the usage of the arrays, and you can as well check the functions that will give you some other ways of using the functions. What we have used in our project right there is the very basic usage of the function. It can be used in a more advanced way, and you have the system reference also with the conditions, and for example the loops, the for each, repeat, etc., the diverse loops that you can use. Be sure to check out as many articles as possible of the manual, even just out of curiosity, but to open up your knowledge of the tools available to you, because the manual does contain everything related to Construct, and if ever you need more help on specific plugins or whatever functions or features or whatever, be sure to check the tutorials and the forums. I hope you have enjoyed this video. Don't hesitate to check out some of the other Construct 2 Academy material. Thank you for watching.